In question 4, we have an electron travelling in a vacuum through a uniform magnetic field of flux density 0.43 millitesla. It moves at a constant speed in a horizontal circle of radius 74 millimeters. In A, when viewed from vertically above, the electron moves clockwise around the circle. We need to choose the direction of the magnetic field. Well, the electron is a moving charged particle in a magnetic field, so it experiences the motor effect. Using Fleming's left-hand rule, point your second finger in the direction of the current. Remember, this is the opposite direction to the motion of the electron, as the electron is negatively charged. Point your thumb in the direction of the force, which is towards the centre of the circle. Your first finger for the field now points down. This is the direction of the magnetic field, represented by -Z. In B, we need to explain why the electron is accelerating, even though it is travelling at a constant speed. Well, acceleration is the rate of change of velocity, and velocity is a vector quantity, having both magnitude and direction. The direction, and so the velocity, is constantly changing as it moves in the circle, so it is accelerating. In C part 1, by considering the centripetal force acting on the electron, we need to show its speed is 5.6 times 10 to the 6 meters per second. Well, the force is given by the magnetic flux density times the charge times its speed, and this provides the centripetal force, mv squared over r. We can rearrange for v. Putting in all the values gives a speed of 5.59 times 10 to the 6 meters per second, or 5.6 times 10 to the 6 meters per second as required. In C, we need to find the angular speed of the electron in an appropriate unit. Well, angular speed is given by speed over radius, and putting in the values given gives an angular speed of 7.6 times 10 to the 7, and this is in radians per second. In part 3, we need to find how many times the electron travels round the circle in 1 minute. Well, frequency is number of times it travels round in a second. This is given by angular speed over 2 pi, which comes out at 1.2 times 10 to the 7 times per second. So the orbits in 1 minute will be 60 times this, at 7.2 times 10 to the 8 orbits per minute.